So everyone, very delighted to introduce my co-founder at Tintash and the CTO of Beacon AI, Murad. So at Tintash, Murad got us all to measure AI's impact on coding and workflows. Um, I was a little like, why are we doing this? But I see now why we did this. And so with that, Murad, over to you. And yes.
Thanks, Manan. Let me try sharing my screen first, and then I can get started. Just one sec. All right. Okay, excellent. So I guess Manan's already done my intro, but just to share a little bit more detail, I in my previous life, I guess I worked at Apple. I was also part of the Microsoft Ultramobile PC division, and I had always an interest in HCI and computer graphics. Did that sort of in my undergrad and master's. I also have taught as a professor at LUMS, and so I had an academic interest in some of the, I guess, topics we wanted to explore. I just wanted to see if we could back up claims that are being made in the industry about AI and its impact on development with real hard facts. Do they actually pan out or don't they? Um, a little bit about, I guess, Beacon, because I think it impacted the way I thought about the analysis we should do. So Beacon, which is a Gen AI company I've been helping steer last couple of years, it has a AI co-pilot for UX design. So there's a lot of AI in what we do. And what we find usually is that when trying to come up with recommendations, like a designer or a design critic, what AIs will do typically is a very good job, but there's high levels of inaccuracy. And when I say high, I mean, even 20% inaccuracy, and the feedback you generate can be really bad. You have a lot of false positives and false negatives. And what we in the company also try to do is heavily use AI for coding and design generation. And we find that often it's very unpredictable. So I wanted to see if we could actually answer the question, where does AI work really well? Like what type of use cases and where doesn't it work really well? And so if we could back that up by data, we have something solid. Um, and so we decided that, that required actually measuring across a whole range of projects. And so we selected about 15 projects at Tintash. And within each project, we wanted to analyze at the task level. So we selected about 100 development tasks. And it's difficult to introduce a process with, your regular sprint cycle where you can actually also measure the impact of AI, unless you're using like what issue tracking software is good for, which is things like the story points that you had versus time you spent, those kind of things. Um, uh, but it doesn't really help capture a lot of qualitative data. And we wanted to capture that too. So we asked teams to report that separately in a Google Doc, or a spreadsheet, depending on the way it was being project managed. One thing I want to add, despite the motivation, which is that to be data driven, there is a reality check that we all sort of acknowledged, and that is the data that we're measuring is imperfect. It's difficult to do an A/B test. You can't ask the team to implement a feature with AI and without AI and meet tight deliverable deadlines. So in practice, while you could certainly do this for a few tests and a few use cases, in practice, it's very difficult to do this in the real world with actual teams delivering products and key features. And so we had to come up with a process that we felt we could actually live with, and that included tracking the actual time spent, the nature of the task, and comparing it against an estimate. And some of that was against historical, the sort of the team's experience with similar work and their estimates, and some of that they captured through asking an AI to do the estimation for the same work. And so that was a cross-check as well. And so I want to say there is some noise in the data. We produced inconsistent results at times. But when we analyzed the results, we felt that the inconsistencies could actually be explained pretty well. And so, I'll make some claims about the inconsistencies and, would love to hear your thoughts about whether you agree or disagree. Um, First, I'll talk a little bit about where we found AI to be really very useful. And so some of those cases were against things that you would expect, like, text generation. So to create READMEs, to create technical docs, to do API documentation, we saw savings of 80, 90%, across the board. It was very consistent. Um, for very simple development tasks that did not require a lot of context, creating a Unity prefab or doing a code conversion from, a simple sort of approach to another. The accuracy was high, the time save was large as well. And so in those two types of scenarios, where there's text generation or there is a simple task, AI shined. It was also, I guess, an obvious result, but we found that data backed that. But across the same team, what we found was that there was actually a significant amount of volatility um, in the um, in the performance improvements. And so this is the graph of one project where we saw a huge, high gain at the beginning, about 40% productivity gain in the first sprint. And we saw that fall off to about 15% in the next sprint, went back up. It fell further, sorry, to 6%, went back up to about 17 and ended up around 4% in the next sprint. And so we felt that there were two things happening. One was there were high initial gains, and as you used AI across the project, your context window would grow, and so the gains would taper off. And so that seemed to be the case. There was also, I guess, a mix of the tasks that were being done by the team. And so depending on the mixture of tasks, whether it's new code or finding bugs, there would again be a difference in the gain of productivity. But the main finding was it was highly volatile. So if you're a project manager trying to plan the gains or wins in the project, you can't, use one number. Your variance could be as high as 30% plus or minus across the project's lifetime. The other thing we found was, and this was mostly reported by the developers, and it was less, I guess, data from within the tasks itself, is the tools that they really wanted to use were often not the ones they could use. And so it wasn't that the best model couldn't produce the results they wanted. So, for instance, one team said they wanted to use the O3 model, and they found it better than Claude in terms of creating unbiased results. But when they were using it, there was high traffic, and some, tasks were taking a long time. In some cases, the tool was not even loading. And so availability of the tool and the speed at which you can use it are also very important variables in which tool actually is going to get used by the team. And not just the model quality. And so, academically, we could say, oh, this model is great and does so well on benchmarks. Well, if it's not usable by the team, it's really not of much value. Then another thing that teams reported was this sort of model degradation trap that you could be in mid-session while working on a development task. And depending on the credits you had, you could suddenly find yourself being downgraded from, say, GPT-4 to 3.5 without realizing. A lot of these tools silently degrade the model if you if you run out of credits, and if you run into that state, you're in the middle of a sprint, you're in the middle of a task. Teams often do not have guidelines around what to do. Should you wait? Should you get credits? Should you wait for the next sprint? What should happen? And so having a specific fallback plan for model degradation is very important when you're sort of managing an AI project in a team. And in some cases, we weren't prepared for that, and so the project teams had to sort of waste a day figuring out what they should do. Then, because a lot of our projects and the way Tintash is, it has customers and clients that are of different nature, different size pockets. We have some enterprise, some startups. So some of the projects had access to the best tools, Claude Pro, Cursor Premium, etc. Others, because a lot of these have to be greenlit by the clients we work with, were dependent on free tier tools. And the performance gain, again, there was something which we couldn't guarantee would be uniform across the org because it depended, heavily on which tools the team could access. And so we saw differences of, about 40%, 30% across different projects. When we started digging into why, we realized that, well, the tools were not the same, and some of them were obvious. But this is a real world constraint, and if you are allocating resources based on the impact different teams have, similar to perhaps the way we had to allocate based on how much revenue we could earn from different customers, you will see very different results. And this can create measurement noise if you're trying to come up with one number across the org. Um, Another thing that we found, which was even, I mean, in my opinion, it was very obvious that this would happen, sort of in hindsight. But that was, if you gain productivity on a task. For instance, that we had a task for a dashboard where the estimate was it should take about roughly a week to build the basic wireframe without AI, and the team was able to do that in about 4 hours with AI. Um, the rest of the time, the rest of the 20 hours, actually got spent doing more work that got introduced mid-sprint. And so instead of being able to compare the gain of 4 hours against 24 hours, the team had actually all this feature creep because you had, AI-enabled productivity. And that, later on, I'll talk about rework and the impact of that. But that actually creates more work and in some ways slows down the team. So you are delivering more features, but then you're also potentially delivering more bugs as part of those features. And so this is something that AI seems to encourage, which is, not just deliver the amount of work you're trying to do, but also additional work because now you can do everything faster. And this also plays out in a different way if you have a very tight deadline. So we saw two different projects, one where there was a very tight deadline. We had to deliver something in 2 weeks versus a sort of a very relaxed schedule of about 8 weeks. The rework required after the initial work was substantially higher in the case of the team that had to urgently get their deliverables done. And so, while there was productivity gains of 80% in the first phase, it dropped to about 30% in the second for the team that was trying to do everything much faster. For the team that had a much more relaxed schedule, the gains were about the same. So they did not lose a lot of efficiency because they had initially spent enough time doing things like looking through their pull requests and properly reviewing them and finding the issues within those, doing more design, all that kind of stuff. And so while you may think that you're really doing everything much faster, you could end up with this sort of average productivity gain, which is actually lower than a team that's working on a relaxed schedule. I've already spoken a little bit about context complexity, but this graph I think makes it a little easier to see. As we worked on tasks that had more complexity, for instance, you had legacy code, and you were trying to make changes in that. So the context-heavy tasks, the gains would fall very sharply. So we saw the productivity almost go down to almost nothing in those types of tasks. And sorry, is there a question? I heard some noise. No, maybe not. All right. And so this, is something a lot of companies have reported, and we know about models like depending on the, this is one of the reasons why chain of thought is not as popular these days as it was in the beginning. But we also found that this is something you can use for task selecting the use of AI. Which tasks you should use AI with and which you shouldn't. We did feel that there may be some ways to work around this. So some teams actually tried um, to try to split the context into sort of different sort of buckets. And so with the idea that, oh, we could summarize the previous context and then we could reuse that, and now you have a shorter window. But resetting also still did not lead to the same kind of efficiency that we would have if there was just less context overall. Whenever you would reset the context, there would be some jump in the efficiency gained, but it would start falling back down fairly fast, and there was a net sort of path down. And so we don't think that resetting context actually solves this problem. So it seems like it's a real problem that we don't have a great solution for. Another thing, and this is what I mentioned with Beacon, that another thing we want to do is to always compare the outputs the AI is generating with real sort of usage of the tool. And so for us, that meant like having everything QA'd as well. So not just like, pull requests and reviews done, but also, have someone sign off and say, oh, this is done, and this actually works like it should. And one of the things we found was it's really hard to get QA to speed up at the same pace as your code generation. And a lot of times this was happening because the context needed for QA to absorb the set of changes that are being introduced is happening too late. It's happening once the task is completed, most of the time. And in some cases, the QA itself, if you are trying to automate that QA, or if you're trying to use AI to write your test cases or run those test cases, there are limitations depending on what you're building. So if it's a Figma plugin or a Chrome extension, or if you're doing something where there's a hardware device involved, it's very hard to sort of automate that entire chain. And so you end up with a person anyway to do some kind of some work in that. And so that again will just slow it down. And so we felt that this is something that is probably an area we as a company need to spend a lot more energy on. So I would say we have a finding here. I don't know if this is where we should conclude, whether the QA is always going to stay in this shape, but it is a big enough problem that I think some great tools hopefully, or products hopefully, will come out that can help with this. In our analysis, we then switched a little bit to delivery and the team structure. So we were looking at tools, we were looking at volatility and all that kind of stuff, but we said, okay, is there a difference based on the way the team is structured? And one of the findings we had was if you have some architect level engineers on the team, someone relatively senior with system design experience, the amount of rework needed once you do some code generation is substantially lower than if you have a team with no one like that on it. And so we saw a difference of 10% to 40% across several projects. And so even if the rest of the developers and the team are not that senior, having at least one person at that level can really make a big difference in the way the project is being delivered. And I think some of that has to do with the initial design and the process and the steps, and some of it has to do perhaps with the reviews. And so we found that having a mixed team could, in some ways, some relative senior junior people could have an impact, but it was volatile. Really, the best mix seems to be have a very senior person available as at least someone who can help you with the design and some of the reviews that you're doing. Then we looked a little bit at the stage of the project. So we talked a little bit about, first sprint, second, and so on. But we also wanted to see, are there specific phases where AI is great, like, the architectural planning stage versus designing your APIs versus doing the front end, and performance or bug investigation. And there also we saw that the earlier phases have high efficiency gains. The later stages tend to get much worse. So for instance, if you're doing UI generation, the first pass is great. You can generate awesome UI. But now once you have the UI and you want to make changes to it, then it becomes harder. And so, across the board, depending on whatever sort of type of task you take a look at, optimization and performance improvements are not as good as the initial architectural planning, design, development, and so on. All right. I think, and I've talked a little bit about this. If we could summarize where is AI reliable and wins, it would be around standalone modules, utilities, documentation research, simple boilerplate code. Where it really struggles is legacy code, context-dependent business logic, and any complex UI. So this was something which I think if you wanted to, you could use as a rule to decide, this is a place where you can gain proficiency, efficiency gains or not. The second practical lesson I'd say is AI is not the same as having an engineer on the team. And one of our developers said it's a bit like Stack Overflow on steroids. And what they really meant was it's great for doing that sort of initial investigation, initial kind of finding sample code you can tweak and so on. And you don't want to switch to agentic mode if you feel like, oh, I can use that to solve for, the pitfalls of code generation, like, code that doesn't compile, etc. Because in some cases, if you give the agents too much freedom, they may even ignore explicit instructions. So one of our team members said, they were finding that almost half of the time the agent was ignoring what he was saying. And in some cases, they can make really drastic and random changes. And so you have to be very, very selective in what you will let it change. But then you also run the risk of it ignoring your instructions. So agentic mode is not a solution. And really, I guess a lot of these are, things that I'm sure many of you have run into. And then I think, there's a lot more that I can share going out, but this is the main set of findings. There's also like some recommendations on what you should think of as a approach. One suggestion from our team was use a toolbox approach, a different model for a different type of task. You should have team assessment cards, like where AI is good, whereas AI is bad as a PM. You should have a clear sense of where you should be confident AI will work and where it won't. And then within Agile, you should accept that you cannot really estimate, at least in terms of execution and delivery, a very specific overall number. You'd have to really look at the sprint to say, oh, we will gain this much efficiency. We used a framework to measure our tasks. Most of this was actually at the task level, so there's a suggestion on how to break it down. And then I would say that as you scale, creating a mandate for how you use AI, providing clear guidelines for the team, including like the tools you can use and the way they behave, having a senior architect on the team. A lot of these are sort of the findings that we felt, where applied were really helping the teams that were working with AI. And with that, I'd like to open to questions because I know that I had 20 minutes. I've gone over. So
Thank
with
you
that,
so much, Murad. I am going to request if you can stop sharing your screen. If I can just have a thumbs up, like if we can just use hands, that's easier. Is that okay with everyone? Okay, okay, great. Um, so I let Zoom take care of the queue. Oh, you're using the actual hand. No, I meant
Oh.
Zoom mic. This becomes hard for me. It's like who's uh okay, if not, we can just Murad, if you can go with chat. Okay, there.
I have a question. I have a
Mike goes
question.
first and then we'll have a queue.
I have a question.
Yeah, yeah. Sam, we need to raise hands using Zoom. That way the queue of hands can be organized. You're speaking on mute also, by the way.
Sorry about
Um,
that.
okay, no worries. So I'll let Mike go first, Sam, you go second, and then we can go to the, if no one else raises hands, we can go to chat. Mike, all yours.
Sure. So, Murad, you said that the improvements drastically diminished with legacy code versus a from scratch project. When legacy code could be 1 year old or 20 years old. Could you say something a little bit about what
yeah.
you mean by legacy code?
So, in our case, we actually don't work on very old code bases,
Okay.
across our projects. So legacy here really meant a large code base, a couple years old, like 3 years old. And so this in particular came from a game we were working on. And so where we had to make some changes into the core loop of the game, which was legacy code, it had been tested and had been around for a while. The changes introduced were awful. Where we had to create some new UI and some new flows, it was great. So it's an
Okay.
example like that. Yeah.
So yeah, so even in that older code base, so long as it was in a new area, you still had good results.
Yeah, because I think it's probably just the context window. There's just so much context that it has to absorb to really understand that it doesn't do a good job.
Okay, great. Thank you.
Sam, over to you. I guess
Okay, I have three questions. I have to drop at the bottom of the hour. But well, first of all, first one's not a question. I think this is great stuff, guys. I think it's really great that you guys took the trouble to do this. This is a topic that's important to an entire industry, right? And so, and it's something that's going to evolve a lot and change a lot, So I think there's room for repeat, progress updates on this. But so that's just one comment. Um, so first question I have is, Murad, you went through a lot of those slides very quickly. Would you be willing to, share those slides with the audience as one question? You don't have to answer that now, but my other question, the real meaty question, is about merges, right? Branch merges. Did you guys look at, that's a very resource intensive thing when it comes to the DevOps tool chain. And did you guys look at doing any of that with AI assisted?
So on the first question, yeah, absolutely. I'd be happy to share. And so Manan can, suggest how, but yeah, happy to share the link of the
I'll
slides
take
with
care
it.
of that.
Around the second question, to be honest, I don't think we looked at that specific use case. Most of this was like, the tasks the development team was working on, that, you could say were standalone features, and there wasn't a lot of parallel development, So
Okay.
so we didn't run into the kind of, you have an existing sort of release, and then you have a branch where you are working on, say, a set of changes, and you need to merge them back after
Yeah.
a long period of time. And yeah, it'd be interesting to check that. So most of these projects, as far as I know, did not involve that
Okay.
kind of
No
stuff.
problem. I thought it was interesting. I thought, that's potentially, potential for AI, and I'd love to see how it does. It could be good, could be bad, but anyway, great job on that, guys. I have to drop.
Thank you.
Thank you, Sam. Adil, you were saying something about open source.
Yeah, I'm curious if you guys had done some exploration around like the non-mainstream offerings. It feels like everybody is leaning towards like ChatGPT, Claude, which are meant for sort of like one size fit all type of models. When we know that there is more and more literature coming out that perhaps for more efficiency gains. What we need is like more fine-tuned models or maybe small language models to focus on specific tasks. So I was curious if there was any exploration done around open source models, like, Alibaba's models are pretty great when it comes to like complex tasks, like Quen. Mixtral's got a pretty good set of tools as well. So yeah, just some thoughts.
Yeah, not in this so in this study we were looking at teams that were were primarily users, and they weren't going to go and like say fine-tune models or change things. And so it was really important that, there was a tool chain that could easily use. So, Cursor was important, for example, and or so that kind of really set the stage for this. But there were other projects where we were exploring that. So we have this project called Clara, which is about trying to audit smart contracts. And there, the team was specifically looking at open source models and fine tuning to improve the ability to find, security bugs in those. And they were much more successful with the fine tuned approach. But then data collection, data, labeling, all of that is an overhead. And if we're looking at like a deliverable of say 4 weeks, it's very hard to sort of set a time for that. Now, if we were doing this at scale, we had the same type of project, and we were going to do it 100 times, definitely we would find that, I'm sure, useful. Yeah.
And with that, I need the show of hands again.
I might have a suggestion, and I think you touched on it lightly around the sprint planning where there was limited efficiency gains, I think, if I remember correctly. I have a personal vested interest in me, but I feel like most of the discourse is around code generation for a lot of these tools, and my product brethren are very happy doing prototyping. But I'd love to see when we talk about agile, it's more than just, PMs and code gen and developers. So perhaps an exploration of these operational type functions and roles like Scrum Masters, project managers, technical program managers, because you guys will have an exposure to a lot of these projects and things like that. So would love to see if there's ghosts in the machines to look at over there or not.
Yeah. No, Adil, that's an excellent suggestion. And the way we were thinking of this is we will run this exercise with the help of our project managers, because engineers are, always so busy. But once we have like the basic sort of code generation tasks analyzed and evaluated, then we will be looking at those other operational tasks. And so that is actually the roadmap we're following. So thank you for the wonderful suggestion.
Okay, so I guess this is it. No more questions, comments. We're gonna call the meeting off 3 minutes early. Okay, thank you very much, Murad. Thank you everyone for joining and the great questions. Hey, Jason, are you okay? I thought Jason had a question for us, but no.
I was just saying thank you. I heard a lot of things that resonate with some of my own experiences, and I'm not nearly as diligent and as much of a scientist about collecting the information. So I really appreciate that somebody out there that's more disciplined and capable than myself like got it all together, and I think it's wonderful. So I just wanted to say thank you, and thank you to Tintash for the invite.
Thank you so much for joining us. Have a wonderful day, everyone. Bye-bye.
Thank you.
Bye. Bye. Thanks, guys.